Well, hello, my dear viewers. Uh, I started the stream because I finally managed to actually resolve some issues when it comes to provisioning OpenStack. So I think today, for the first time, we'll end up with somewhat functioning OpenStack deployment. Na jakąś animację. W sumie miałem kiedyś takie animowane tła, ale musiałem to ustawić jeszcze raz. Anyway, let me switch back to English because I think this VOD will be somewhat successful. Just so you know, I do plan on making like a dedicated YouTube episode about this, but I really wanted to have this out in the ether just so that there is like a somewhat functioning and working OpenStack deployment. So just to summarize, once again, I am using, like, I've based most of my know-how on this tutorial from Kolla Ansible, and it does give you an information on how to deploy OpenStack version 2025.2. I think the latest one is 2026.1. But I will be probably testing the upgrade paths and stuff like that. This thing, later on the stream, or maybe on some later streams. It has my topology that I am using. So 7 VMs in total, 2 network interfaces on each, one for management network, one for public network. One big asterisk I am doing in my deployment is I am using IPv6, and this is probably the reason why not everything has worked last time. But I will get to that. I will show you what I had to change that actually made it working. Shout out to my trainer from my OpenStack training that I have at work, who pointed me to how to fix that issue, because I really spent like 3 evenings with ChatGPT, reading logs, stuff like that, and I couldn't figure it out. So once again, this is the tutorial, and I have some of those steps done. Sorry. I have some of those steps done. Basically, this one, the deployment of the Kolla Ansible virtual environment and Kolla Ansible package. The rest I'll be doing right now, basically. So yeah, just to show you again, I have 7 VMs, 3 control nodes, 3 compute nodes, and 1 storage node. One thing I discovered is that you should, I would say, have more than 2 virtual CPUs or cores or whatever, at least on control nodes. And the reason for that is that RabbitMQ binds to 2 cores. And while it shouldn't be an issue, it can definitely impact the performance because it is technically bound to your 2 cores that all other services on the control node are also using. So I would suggest at least 4, maybe even 8. Compute nodes can be whatever. Let me check how much RAM do I have. On control nodes, I have 32 gigs. I think that's, 32 from what I see in the performance monitoring is a reasonable amount. On compute, you can have whatever. I have 16. And on the NFS node, I have like 16 gigs, but it's using like 6 gigs. So it's not that important. One other note, I have 8 VMs because the 8th VM is the one I am using for deploying the Kolla Ansible playbooks. And basically, it is my bridge from IPv6 to IPv4 land. So there is like one additional VM here. Basically, it's called Bastion, and if I show you the the CLI. This is the 8th VM that wasn't visible on that picture. So, without further ado, as you can see, after you follow that section 5 from that tutorial, and it will be linked in the YouTube VOD description, whatever, I will post a link. You'll basically end up with virtual env as soon as you enter sudo. And now I have to prepare my other VMs. So I have a script called prepare.sh, and that script is, first of all, exchanging root SSH keys to all of those VMs, which also means that I had to log in manually to all of them and enable password root login in order for this to work, this SSH copy ID. Then on every one of those nodes, I am updating and upgrading the packages. I am installing, as the tutorial said, cronny, rsyslog, iputils, ping, and NFS common. The NFS common is basically there to be able to mount the NFS share. Then I'm enabling the cronny and rsyslog services. And then I am doing something that's specific to Ubuntu. I am extending the root partition and resizing the file system, because by default, if you install Ubuntu from its installer and you let it partition the drives however the Ubuntu installer wants to, and for example you give it like 128 gigs drive, the Ubuntu will by default use half of that space, and the remaining space will be unused as volume group. And basically I am extending the root volume and resizing the file system just to utilize all of the space that the partition provides. I mean, Ubuntu is sometimes so weird. Some decisions baffle me when it comes to Ubuntu installer, but that's basically a hate topic for another time. And then some commands specific to the NFS share virtual VM, because by the way, OS con means controller, com means compute, and OS NFS is basically our Cinder volume exporter. So for the NFS VM, I am installing the NFS server, basically NFS kernel server. I am creating the directory. This is specific to my case, but basically this directory will be exporting the NFS share. Change mod 777 for that directory. Then I'm echoing the NFS export share to etc exports. And then I'm verifying that everything works with export fs, and then I'm also enabling the NFS server to be persistent across reboots. The last thing I'm doing is I'm populating the etc hosts on all of those VMs, which basically means that, because I have two files here, right? I have prepare.sh and hosts file. So in my hosts file, I have some local basically host entries, right? So if you don't have like public DNS to resolve your domain names, you can go with that. So this is basically entries for all of the VMs. OS Bastion is also there, the host I'm deploying the Ansible in. I don't think it's required, but it is there. And VIP OpenStack local is an entry for the floating IP. So this IP will be floating across control nodes. It's basically for high availability, and I'm also giving it an FQDN name. So first, let's run the prepare.sh, but let me also prepare one thing. Prepare.sh. So I have password copied, and by right-clicking I am inserting the password. So this is why you're seeing happening it this so quickly. And now it's installing all of the packages, and it will be performing that initial configuration. So this should be done in a minute. It's not really that long. But all in all, I did have a lack of just deploying it today and having it working. Bear in mind that what I'm showing you is only basically a quick start on how to get started and how to have somewhat working deployment. If you want to deploy this in production, you definitely need to give it more thought. You definitely need to basically think about a lot of things. Your IP access, your IP networks, how many networks do you want to have? Is this architecture good for you, right? Because what I'm doing here also is something I haven't mentioned in the beginning. I am doing basically a minimal deployment. So just a handful of OpenStack services, basically Cinder for volumes, Neutron, it has to be there, right? Horizon for dashboard, and pretty much nothing that wouldn't be required as core, right? So no ironic, no service discovery, no auto discovery, no stuff like that. And also, I'm not an OpenStack savant, but I do think that the internet lacks that kind of knowledge when it comes to OpenStack. Like, this is really, I want to say, one of the final frontiers when it comes to big scale system deployments, right? You can basically learn how to deploy Postgres and scale from there to multiple nodes. You can do that with databases. You can do that with web apps. You can do that with Nginx, with Apache, with load balancers, stuff like that. But when it comes to OpenStack, there is a big gap when it comes to deploying a single node OpenStack versus multi-node OpenStack. There's just so many philosophies when it comes to deploying that stuff. I would even go as far as to say that deploying OpenStack is way harder than Ceph and a file system or storage systems. But I do have to say that Kolla OpenStack is the method of installation of OpenStack that kind of changed my view when it comes to it. Like, it really is simple once you get the hang of it, and it's also really simple when it comes to tinkering. If you want to change something, if you want to tune something, I would say that it is easiest to do with Kolla, in a way where you are not breaking your entire installation and you would have to roll back the entire server just because you've changed one config and everything went down. Because like I said, this is just a stream to show everyone and basically have a video proof that this works. I will probably have to make a YouTube main channel video explaining, the whole process of how complicated this can be, or how many methods of installations even are there for OpenStack, which is basically interesting in it of itself. It's like, I think even OpenStack website has those charts when where they show which method of installation is the most popular. Yeah, almost done. To be honest, this could be done in parallel. This could be just working in parallel, but here we are. In hindsight, this should be all done in parallel. I think I know what it's doing. I think it's only doing the etc hosts now. That we have this. It also says that I need to reboot the computer now, right? So I will do just that, and I will do it from my Proxmox console, just to have kernel consistent. This will be really, really quick. So I am clicking reboots on all of the VMs. And while they are rebooting, I will talk about Kolla. Okay. So they are rebooting right now. Let's go to etc Kolla Ansible. And once again, just etc Kolla. Once again, like I said, I have done the paragraph 5 of that tutorial I showed you. It will be linked in the video description. But this is really, really easy, and let's not waste our time like doing that all over again. I assume if you want to do OpenStack, you have at least some basic knowledge when it comes to stuff like that. Anyway, there are two main files of interest for you here. One of them is multinode, which is basically an Ansible inventory. And those are the names that I have used in etc hosts. And they basically define the topology that I've shown you in that image. So for control, I have 3 hosts, OSCon 1, 2, and 3. For network, I have also my control hosts. For compute, I have my compute nodes 1, 2, and 3. And for monitoring, I have my node OSCon 3. For storage, I have OSNFS. And the rest here is basically inheriting all of the nodes configuration from those first inventory items. And this file is the important one where I had to make a change to make everything work. Webfish, ciekawi mnie wybór distro, czemu Ubuntu? Webfish asked why I'm using Ubuntu. Basically because Ubuntu is one of the few supported distros for OpenStack. Po prostu Ubuntu jest, OpenStack wspiera tylko niektóre dystrybucje, znaczy nie tyle OpenStack, co Kolla Ansible wspiera niektóre dystrybucje. Stąd po prostu wziąłem tą najpopularniejszą, pod którą OpenStacka można postawić. Jest Rocky Linux, ale ogólnie te Red Hatowe distra, tak bym powiedział, że pół na pół. Trzeba tam się czasami wczytywać, bo mają swoje quirki, mają Linuxa, jakieś tam inne rzeczy. I z tego, co tak się rozpytałem, to chyba pod Ubuntu jest to wszystko najlepiej przetestowane, najlepiej działa i po prostu najspokojniej jest. But going back to what I was saying about this inventory item, Rocky na zawsze w serduszku. Czekaj, nie mam laptopa, ale mam na moim laptopie naklejkę Rocky Linux, mimo tego, że w sumie nigdy mało gdzie korzystam, mało gdzie wdrażam, bo już albo wszędzie Debian, albo wszędzie Ubuntu. But going back to this inventory, this is the place where I had to make my life-changing change, basically. So the problem I've had, and you could see me basically struggling with on my previous live stream, is that by default, RabbitMQ, the queuing messaging system for the OpenStack, tries to deploy itself as a cluster of, in this case, three members, right? So basically, RabbitMQ is split into 3 instances joined in a cluster, right? The problem I've had is that configuration wouldn't start. The cluster members couldn't contact one another. And from what I discussed today, the problem might, I'm not 100% sure, the problem might have had something to do with my pure IPv6 configuration deployment. Because when I changed this to just tell it to, hey, just configure RabbitMQ as a single node instance, and basically all of the services in the OpenStack will be just, instead of like being able to connect to different instances of RabbitMQ, will only have one centralized instance of RabbitMQ. No clustering, no stuff like that whatsoever. So this is basically a single point of failure, to be honest, right? But it's a trade-off I'm making to just make this work. I'm just also telling you that just so you are aware. So basically, instead of RabbitMQ cluster, I am just switching to single RabbitMQ instance on a single node. And this might have had something to do with my pure IPv6 deployment, even though from what I've read, this should work. Maybe on some next live stream, I will check that. Maybe I will just do pure IPv4 deployment, and then I will go back to RabbitMQ in a cluster mode. So once again, very important, if you also have problems with RabbitMQ and you also want to try pure IPv6 thing, change this to this, and you should be happy. As for the other configuration file for Kolla, globals, and there is a lot of noise here, right? Every option is explained. You should definitely read this file because it's not necessarily that long. It has like 870 lines, but you will most probably not be interested in half of those sections, at least not in the very beginning. So let me just show you the options I have actually configured. So let's not display anything that is a comment, and let's skip the empty lines. So as you can see, this is literally everything I have configured and told Kolla Ansible, right? Just this handful of lines. So workaround Ansible issue, this has something to do with Ansible. Kolla based distro, I'm going with Ubuntu here. OpenStack release 2025.2. You basically don't touch this. This is basically tied to the Git repository that you have pulled the Kolla Ansible from. Kolla Ansible VIP address, virtual IP address. This is the IP address that I've shown you in my hosts file. This is the floating IP address. It will basically be floating across the controller nodes. Kolla internal FQDN. Here, this is basically IP address. You can configure it. I have uncommented this because I was trying some stuff while trying to fight my RabbitMQ problems. So in this case, it will be using just the IP address. You can also configure or actually let me change that. FQDN. Yeah, as you can see, uncomment this and comment that. So this is the DNS domain name that will be used for the services in the OpenStack to reach the virtual floating IP. Network interface ENS18 and a neutron external interface ENS19. In my case, since all of the VMs are identical, they have the identical configuration when it comes to network interfaces. If you have like varying configuration when it comes to that, you can configure your specific examples in the inventory. So in the multinode file, and this is definitely described in the Kolla Ansible documentation. So network address family, in my case, IPv6. And the next is basically, the next part has to do with what services you're enabling. So enabling Cinder, yes, for our volume and storage needs. Cinder backup also yes, and backend NFS also yes. So basically we are telling Cinder to provide us volumes and to also be a backend for volume backups and to use NFS. Those options I have uncommented, but they were pretty much default. Actually, this is a leftover from my debugging with RabbitMQ. So This I will actually delete in a second. This is not required to specify that. And those options I haven't changed at all. I have just uncommented them when I was debugging the problem. So all in all, you can skip all of this RabbitMQ section. Cinder backup and backup driver NFS and Cinder backup share basically tells it where our NFS share is. Nova compute virt type QEMU, because by default it's libvirt. I have changed that to QEMU as per the tutorial I have shown you. So let me also do as I have told you and fix those RabbitMQ options. So this goes bye-bye, this goes, and this goes commented out. And with that, we are pretty much ready to start. So Kolla Ansible pre-checks, and now I have to point it to my inventory file. Okay, this is without dash in the middle. So this will probably fail, and I will tell you why in a second. Yep. Yep, no, yep. It's failing. Why? Because those virtual machines haven't been bootstrapped yet. So by bootstrap, I mean they don't have anything like Docker installed and stuff like that. But Kolla can help you with that. It basically has an option to bootstrap servers. So basically it installs its own dependencies. So let's do just that. Kolla Ansible bootstrap servers and our inventory file multinode. It basically will install only those dependencies that are relevant to the role of the VM. So now it will do just that. And I will also check one more thing on my NFS storage node. Yeah, everything should work. Okay. Okay. So yeah, this will take a second. It basically, like I said, is installing Docker or basically anything it might require. And after that, we will also do one important thing. So, like I said, once you get the hang of it, okay, it's done. And once you get the hang of it, it's mostly waiting, right? So now, before we actually deploy, I would say it is a good practice to pull the images beforehand onto your hosts, just to have them sitting and ready. One other interesting thing I've learned today is that if you are doing this for production, if you are basically deploying OpenStack for production, you also must configure your own image registry where you have your own images built. You shouldn't rely on the images that are in a public repository, and basically it's not a schizo talk. This is something that I was told today, that it is actually quite simple to inject your own poisoned images into the public repository. Basically, somebody has extracted, just for fun, not necessarily a bad actor, a friend of a friend basically, has extracted some repository keys and was able to upload his own version of images to the OpenStack images service images to the public repo, right? So basically, my answer to the question I asked today, which was what container image storing backend are you using, or what caching layer or solution are you using, was that we are not using a caching solution. We are using our own deployed image repository. because we are building our own images, and it's also way simpler if we want to modify those images, right? If we want to, for example, include a driver that is in there by default, or if we want to make some configuration change that is very specific to our own deployment and environment, right? So I guess I could do a series of videos called Road to Production OpenStack, where I basically try to go through all of those hoops and deploy like all of the services required to run OpenStack, like that surround the actual OpenStack instance. But just so you know, right? I would really say that I really wanted to say that the amount of tutorials that you have on the internet that basically tell you that you will have an OpenStack, and then they will proceed to give you a tutorial for a single node deployment is baffling me. And on the other hand, you have tutorials that actually do give you a working multi-node deployment. The problem with that is that they basically have a length of 3 hours, and it's basically a tutorial in the form of an unscripted live stream where basically a lot of time is wasted, right? It's not like edited in a digestible, comprehensible way. Okay, today, so not really any issue with pulls today. I am surprised. So now we can actually hit deploy. So as you can see, Kolla Ansible deploy, and we are pointing the Kolla Ansible to our multi-node inventory file. So let's not waste any more time and just go. And while this is going, you'll have the pleasure of me of hearing me ranting about some other random things on YouTube I have noticed recently. For example, I wanted to learn more about Authentic. By the way, I should probably display something like this is my unhinged opinion, my unhinged rant. That's basically a filler for what's happening on the screen right now. Anyway, I wanted to learn more about Authentic, and Authentic is a solution that helps you manage users. I want to say I would also describe it as a product that basically can help you replace LDAP and possibly Keycloak, because it's doing things that Keycloak is not really designed for. It can be your source of truth when it comes to users in your organization. I don't want to necessarily say domain, but it also can act as a piece of software that is intermediary between your source of truth for the users and basically somewhat like an abstraction layer for authentication systems. So it can like support your OID or SAML or whatever MFA login solution, right? So anyway, just Google it, right? Authentic with K. I wanted to learn more, and I want to say year ago, maybe something like that, you could definitely see that Authentic put out like a lot of sponsored videos. Basically, a lot of high-profile YouTubers uploaded a video on Authentic that showed you how Authentic works, some basics, and that's fine. Don't get me wrong, that's completely fine. But they did. All of them ended up doing the most basic example. So basically, from what I've heard, this works in a way where your sponsor, in this case Authentic, basically provides you, the YouTuber, with a script and with a scenario that some example scenario that you should follow and present to your viewers. And like I said, that's fine. What irritated me, what I was irritated with, was that there were absolutely no, or very few, I'm not sure if I've seen any YouTubers that actually tackled more intricate architecture deployment or features in Authentic. I think there was only one guy, and still, he was basically sponsored by Authentic. So he may have been the only YouTuber that not only was doing more intricate videos about Authentic, but he was doing it because he was paid for it, right? I'm not sure where is it coming from. Like, nobody really wants to do videos on, I would describe it as production grade deployments or production grade feature explanations. I wouldn't say that nobody is doing that because it's hard, because even like basic explanations can be hard, and people are still doing that when they are not necessarily sponsored, but still. Ale długo stawia. Nie stawia tak długo. Nie stawia tak długo, wierz mi. Znaczy, to co on w tej chwili robi, to po prostu wgrywa konfigurację, odpala kontenery, restartuje je. Część tych kontenerów jest sklastrowana, czyli on tak naprawdę spinuje klaster. Tam na przykład wcześniej była MariaDB, ona się na czerwono świeciła, ale ona się świeciła na czerwono dlatego, że on po prostu ją odpalił i ona jeszcze nie zdążyła wstać jako ten klaster, więc chwilę poczekał i jak się był w stanie do niej dobić na tym VIP, na tym floating IP-ku, to dopiero wtedy uznał, że jest OK i poleciał dalej. Natomiast no, za chwilkę skończy. Tak, powiedziałbym, że jeszcze nie więcej jak 3 minutki i będzie gitara. So yeah, my rant about Authentic is I think mostly that, like the Authentic was an example, but overall it is like that with the non-obvious software solutions. They basically have very, very basic tutorials, like the high-profile YouTubers. And this is also funny because whenever you see a high-profile YouTuber give out a really comprehensive, well-explained video about a solution or a piece of software, it is like this mostly because he has received a script from the authors of the solution or the software to basically tell him exactly what to do and what scenario to follow. And with some high-profile YouTube creators, it is cleanly visible whenever they have a scripted, paid sponsorship video and when they just came up with something on their own. I think last time I saw an extreme example of that was with Network Chuck, whenever he was doing Rancher tutorials for Kubernetes from OpenSUSE, and I was like, damn, that's like a very good tutorial. And then I switched to some other videos and the quality was basically up and down, up and down. Fajnie, że są takie automaty. Nie można sobie wklepywać i przyklejać tyle rzeczy z doksów. Wiesz co? Znaczy, to jest jeszcze w ogóle o tyle skomplikowane, że znaczy Kolla Ansible nie jest jakimś czymś kompletnie nowym, tak? Bo to, co robi Kolla Ansible, by the way, if there are actually some English viewers in chat, do say hi, because then I will know to not let myself switch to Polish for a longer periods of time, by the way, okay? Z Kollą Ansible jest trochę tak, że to, co jest fajnego w Kolli, to jest to, że ona ci stawia te wszystkie serwisy w kontenerach, tak? Czyli na przykład nie próbuje ci na gołym Ubuntu instalować tych wszystkich zależności i serwisów. Bo problem jest taki, jak one wszystkie mają jakieś zależności, na przykład jeden serwis jakiejś nowszej biblioteki. This guy 100%. Wiesz, najgorsze jest to, że w kontenerach masz pełną izolację dependencies, tak? A jakbyś tego nie miał, to się wszystko potrafi żreć. I te wczesne metody instalacji OpenStacka, no to często właśnie były takie, że no musisz mieć Ubuntu 18.04 i brońcie Panie Boże, ręka boska niech cię broni, żeby nie upgrade'ować Ubunciaka, tak? Albo właśnie, że no jak musisz podnieść, to musisz podnieść wszystko i w ogóle twój setting się rozwali i się rozepnie i trochę dupa zbita. A tutaj stawiasz wszystko w kontenerach i muszę wspomnieć uczciwie, że są jeszcze inne metody konteneryzacji, bo są jeszcze, nie pamiętam tylko nazwy, metody instalacji OpenStacka, gdzie zamiast w kontenerach dockerowych instalujesz w kontenerach LXC, nie w dockerze, To jest trochę inne podejście, dużo gorsze moim zdaniem, no ale są głosy, które to lubią. Nie wiedziałem, że takie rzeczy istnieją, czytałem dopiero chwilę. OpenStack to jest chmura. Chcę powiedzieć tak w dużym skrócie, jeżeli na przykład widzisz AWS-a, OVH, inne takie rzeczy, to one stoją na tym, na OpenStacku, tak? Nie mówię Microsoft Azure, bo Azure ma swoją chmurę opartą o Hyper-V, więc oni chyba niekoniecznie mają tam OpenStack, ale ręki sobie nie dam uciąć. No ale jak jesteś takim prowajderem, który dostarcza, sprzedaje VM-ki, no to masz na 99%. To w ogóle to jest software, który jest używany i chyba, jeżeli dobrze pamiętam, wyszedł z CERN-u. W CERN-u są takimi hyperscalerami, że po prostu ten soft był im niezbędny, a teraz to już w ogóle. Elixir to chyba kiepskie rozwiązanie, chociaż nie wiem. Znaczy w Elixir tak naprawdę najgorsze jest trochę to, że nie masz takiego huba obrazów, jak masz w Dockerze. Znaczy to jest moim zdaniem, tak? Może ktoś powie, że jest jeszcze tam dużo innych rzeczy, bo tak naprawdę no, kontenery wszystkie działają w oparciu o te same zasady i tę technologię. Natomiast to, co jest w Dockerze trochę rewolucyjne, to jest to, że pobierasz sobie obraz i masz ustandaryzowane API do tego i możesz postawić sobie własny rejestr obrazów i to działa. W Elixir to nie jest do końca to, tak? Też możesz mieć tam swoje templaty, ale no nie masz takiego standardu, tego rejestru przechowywania tych obrazów. Czy da się w Elixir odpalić z kontenera dockerowego obraz? Pewnie się da, bo to się tam chyba wystarczy nawet wypakować targezetem. Ale mimo wszystko Docker ma dużo więcej tych narzędzi i tej mocy deweloperskiej i użytkowej naokoło siebie. To jest to, czego nie ma LXC. Jeszcze tym bardziej, że było LXC, potem jeszcze było to LXD, jeszcze potem system nspawn. To jest tak naprawdę dokładnie tym samym, tak? A Docker to jest, znaczy, no, to jest temat rzeka wszystko, nie? Systemy kontenerowe. Jest bardzo fajna książka a propos w ogóle konteneryzacji kontenerów, nie wiem, Kubernetesa. Cholera, jaki ona miała tytuł? Mam ją fizycznie, gdzieś tutaj musiałbym wstać i ją przynieść, ale nie mogę sobie teraz przypomnieć tytułu. Chcę powiedzieć Kubernetes dla opornych. O nie, znalazłem, dobra. To nie jest reklama i nikt mi za to nie zapłaci, ale Faket Kubernetes przewodnik po orkiestracji kontenerów i tworzeniu niezawodnych aplikacji. Bardzo fajna książka, głównie ze względu na to, że bardzo niskopoziomowo fajnie zaczyna wyjaśnienie, czym jest kontener, od tego, jak to naprawdę działa w systemie. Ja to Bobas jestem w te rzeczy ostatnio, wstawiałem sobie stronę na RPI. No, zawsze gdzieś trzeba zacząć, prawda? Chociaż ja się strasznie od malinki odwracam, bo znaczy odwracam w tym sensie, że uważam, że Raspberry Pi jest do takich naprawdę albo do jakichś takich zastosowań typu, że się uczysz, albo że masz jakieś takie naprawdę wiesz, że to zastosowanie jest bardzo lekkie, twój use case, bo sobie z ciekawości kupiłem, do kamery teraz nie pokażę, mam chyba za krótkie kable, ale mam Pi0, które robi za serwer DHCP-a i no po prostu widać, jak to się męczy i nie wyrabia. Tam stoi Pi-hole i to po prostu tak bardzo się męczy, że jak tego nie zrestartuje raz w tygodniu, to trochę umiera. Malinka kiepska, ale wiesz, nawet nie chodzi o to, że to nie jest procesor wydajności Ryzena nowego, czy coś, tylko właśnie, że nawet jak stawiam jedną usługę, to sam fakt, że to jest karta SD i inne takie sprawia, że ona nie daje rady, nie ciągnie. Na HomeLab to szybko jakiegoś odświeżonego Optiplexa do zabawy. Tak, tak zwane cienkie klienty, Thin Clients na Allegro można kupić za 100 parę złotych i one mają wszystkie wydajność co najmniej najnowszej malinki, jak nie większą, tak? I wcale nie mają dużego poboru prądu, tam 15 W, nawet mniej chyba. 15 W to z dyskami twardymi. Okay, because I will probably be clipping this for Twitch or YouTube or whatever. I will switch back to English. It is done. It is done. So it has successfully deployed. but you know, previously it also has deployed successfully, but I was having issues, so we will verify everything in a second. But before that, we will do post deploy. And post deploy will basically populate my environment with, most importantly, this thing. This thing is the thing that lets me have CLI access to the cloud I have just provisioned. So if I now do OpenStack services list, not services, service, you can see I have my services deployed, right? Cinder, Neutron, Glance, Placement, Heat, Cinder v3, Heat, Nova, Keystone, all of the basic services are deployed. And previously, OpenStack volume service list. Previously, those two were enabled but were down, which means that this is how I knew that the previous setup did not work, right? This is how I knew that the previous setup had problems, because by them being enabled but being in a state down, they weren't able to register themselves to RabbitMQ messaging queue. But yeah, all in all, this should be all. Okay, have I closed my Chrome window? Okay, I need to reconfigure this little fella. And voila. By the way, you can ignore this domain name because it's a locally resolved address. You will not be able to enter this. But just so we know, we can go to admin and I am inserting my password. Password for this, if you follow that tutorial I have shown you previously, you are setting in a YAML file, right? So you can do that. And this is Horizon dashboard, right? And this is something that I have had previously also, but there is one helper file that will initially populate your OpenStack deployment. So I will help myself and grep for once, and this is the script. Basically, server Kolla vn share Kolla Ansible initialize run once, init run once, and this will basically create some sample flavors. It will import some basic image types. So let's do that. And one important note, because my IPv6 setup was flawless. I mean, let's ignore the fact that RabbitMQ was not working. The problem came out at the very end. Oh, yeah, sorry. I will show you. Okay, good eye. I will show you that in a second. The problem with my previous IPv6 only deployment was bafflingly the fact that GitHub does not support IPv6. So if you try to download anything from GitHub using IPv6, it won't work, which is dumb as hell. Okay, I basically executed this. srv Kolla vn share Kolla Ansible init run once. So it is basically making some initial configuration. This is not required, but actually this will be a good test to see if everything is working. So let me switch back to the browser. Let's refresh everything. And let's create an instance. So nazwijmy, let's call it test instance 1. Yo, it's not required, but hell. Source boot image, volume size 1 GB. Zeros. This is the distribution that was imported by the init run ones. So we will be using that. Flavor, that script also created those flavors. So let's go with M1 tiny, so 1 vCPU, 5012 megs of RAM, and 1 GB drive. And network, let's use demo network. And all of that is not required, so let's not delve into that. Launch instance. Okay, I pressed enter, sorry. It is building, block device mapping. Spawning. And I have, I think, one bad news, but we will see. It's spawning. And it's running. Yay. So basically, what has happened now, we have successfully created a VM, a virtual machine. It has some internal network with some fixed IP. In the logs, we can see that it has basically started, but I don't think I will have, I will not have a working virtual console, virtual KVM, because my floating IP, my basically gateway into my OpenStack services, is first of all not routable from the global internet, and it's not accessible through my current VPN. So if I had configured my network properly and properly exposed it to the world, I would have this working, and you could see basically a VNC window or no VNC window to the console of the virtual machine. So you can imagine, wait. Let's do a quick switcheroo. You can imagine it would look somewhat like that. But like I said, I have not configured the virtual IP, the floating IP properly. So this is what we get. And basically, we have to trust the OpenStack console itself that it is basically successfully running. I am pretty sure we could also attach to that instance from this CLI console. But to be honest, I don't necessarily remember how could I do that from the top of my head. OpenStack image list. We have zeros, OpenStack instance list. No. So like I said, I am not OpenStack savant. I am still learning, but I do think that just showing how can you deploy your own multi-node instance is very, very important, right? So yes, this is something that has not worked before, especially with the volumes. Now we can see volume. Actually, let me try one thing, because if it is configured for backups, then I want to try and make at least one backup, just so I know. Create backup. Test volume backup 1. Create backup. Let's see if it works. By the way, I also do find it. Yeah, let's check networks. Oh, okay. So basically, DemoNet has 10.0.0.0/24 defined, because I was wondering whether my IPv6 only instance for management will be able to utilize IPv4 addresses when it comes to creating networks, but it looks like it's working fine. So basically, the users of the cloud uh, don't even need to know that under the hood everything is running with IPv6. Though, like I said, I have to diagnose those RabbitMQ issues, and we'll see. We'll see. Okay, is the backup done? It is done. And if I am right, SSH OSNFS, Kolla NFS, and you can see that there are some volumes, and probably our backup is also here. This probably I would guess that this might be it. Yes, this is it because this is compressed. Backups are compressed by default. So this has to be our backup. Okay, big yay. Big yay, big W, because after a very, very long time, not only have I successfully tried out an OpenStack tutorial and somehow got it working, finally, people will be able to link to my live streams and tell that this tutorial is working while actually having a working method like shown in the VOD in the live stream. Because what happened, I think a year or two ago, I was also trying some other methods, especially canonical Ubuntu Sunbeam method of deploying OpenStack, and I couldn't get it running. I couldn't just start it. It wasn't working in the multi-node deployments. It was just breaking and stuff like that. But I did make the live stream VODs public with the title of trying out OpenStack tutorial Sunbeam. And I really did have some people from Reddit just link me my own tutorial where I was not able, not stream tutorial, my stream VOD where I was not able to install OpenStack using that method, and tell me, here you go, a working installation tutorial for OpenStack canonical Sunbeam. So finally made that curse end, uh, and I think this is somewhat working. So um, I want to say this is a very cool home lab project. If somebody wants to try that, the problem with that is you need a very worse over exactly. The problem with that is you need a hefty server to deploy it. Like, I want to say, somewhat in a reasonable scale and manner. Because if we add this up, like, let's just add how many gigabytes of RAM I have used to deploy all of that. So I have launched calculator app. So 2 gigs for my Bastion VM. 32 times 3. 32 plus 32 plus 32, which is 96 gigs of RAM plus 298. Now for the compute. 16 times 3, so 16 plus 16 plus 16 is 48, which gives us 146 gigs of RAM. And finally, plus 16 for my NFS share, which gives us 162 gigs of RAM. for this. And you can actually see that for the compute nodes alone, RAM used 512 megs out of 93 gigabytes. Yes, RAM is very expensive today. It's hilarious how expensive it is. Like it is especially hilarious when you like ordered your for work your HPC or cloud system last year. You have signed a contract and the RAM prices have gone up. And trust me, you don't want to be in a position of a company that is like delivering and installing your cloud, and they are basically like, you know, they have to cover the difference cost of what happened during a year when it comes to memory. But it's so weird what happened to RAM. But you can see that this is using like 100 gig to just have something for compute. And optiplexes. Optiplexes. Or optics. I assume you meant optics. But yeah, optics too. I mean, optics also like always have been somewhat expensive, I would say. Maybe even more so now, but yeah, I guess I agree. Well, okay. So, I guess that's all what I had for today. I need to wrap up. I don't want to say early, but I do have like an early morning tomorrow. And I still need to cut this VOD. DDR3 still exists. It does, but is it hot optiplex in your area? Is DDR3 usable? I would say that especially with DDR5, there is way too much performance gain to even consider DDR3. I think I still have a terabyte RAM, a server with a terabyte of RAM. It might be DDR3. Czekaj, może zostawię ich OpenStack tylko 100 zł. Gorące serwerki w twojej okolicy. No cóż, no powiedzmy, że już ta część oficjalna skończona, więc tam sobie potnę, ale że tak powiem, OpenStack się trochę nie nadaje, żeby na przykład postawić sobie OpenStacka i potem postawić sobie masę cienkich klientów, czy jakichś takich innych, nazwijmy to w skrócie brzydko, gównianych klientów i na nich sobie robić jakieś worker nody. Do tego się dużo lepiej nadaje Kubernetes. Na Kubernetesie na pewno możesz tak zrobić, że nawet możesz sobie zrobić jakiś jeden taki może minimalnie grubszy host na control plane, na control noda i powiedzmy zrobić sobie tam, nie wiem, 100 Raspberry Pi'ów jako worker nody. Na popularnych portalach audycyjnych jest tego pełno. Nie, no jest tego w bród. Natomiast no, ja trochę mam taki syndrom tego, że trochę się boję kupić za cienkie gówno, bo bardzo szybko z tego jestem w stanie mentalnie wyrosnąć w ten sposób, że jestem sobie w stanie bardzo szybko wyobrazić use case, gdzie chcę postawić jakieś usługi, któreś tam nie zmieszczą. Dlatego i tutaj pewnie będzie wszystko bardzo brzydko wyglądać, bo chyba na Chromie nie mam konta, ale na swoim YouTubie, o patrzcie, streamuje typ, na swoim YouTubie mam Building My Dream NAS on the Chip i tak naprawdę i najważniejsza jest obudowa. W sumie wychodzi na to dla mnie, bo jak sobie kupisz dużą obudowę, no to oczywiście zapłacisz trochę hajsu, ale ta obudowa zostanie z tobą dłużej niż połowa tych komponentów. Jest dysk HDD gratis. No wiesz, no mogą sobie być te dyski tam, czy to, że w ogóle jest dysk gratis, czy tam nie wiem, czy RAM gratis, bo czasami bez RAMu sprzedają. Wiesz, no tak naprawdę siłą tych sprzętów jest to, że pomimo tego, że one są 5-7-letnie, one nie są aż tak słabe, a nadal są bardzo atrakcyjne pod kątem poboru mocy. W sensie, że tam nadal masz pobór rzędu 10 W, 7 W, 15 W, nie? To jest ta obudowa, co ja zamówiłem. Ona jest super, bo do niej po prostu wejdzie normalna płyta taka desktopowa ATX i wejdzie też ATX, nawet jeszcze większa płyta. Aha, no już się ma reklamy. Niektóre są w miarę upgrade'owalne, no RAM tam wymienisz, to nie zawsze, tak, no bo w szczególności jak tam jest DDR3, to jeszcze trzeba patrzeć, bo DDR3 to był DDR3, a potem był DDR low voltage. Potem się okazuje, że te płyty tam wspierają, nie wiem, maksymalnie 8 GB RAMu, 16 GB RAMu, nie więcej. E, Więc trochę z tym jest syf, tak? No mówię, ich największą zaletą jest to, że po pierwsze są x86, czyli nie są gównianym ARMem Raspberry Pi'owym, który jest ARMem, ale tam nie ma HW Clocka, nie ma jakichś tam innych rzeczy i jest w tym trochę syf. To, że najprawdopodobniej mają normalne porty SATA, że możesz tam podpiąć kilka dysków, a nie tylko przez USB 3.0, tak jak w Malince, czy tam jakimś PCI razy 2, jakiś gówniany NVMe wsadzisz, tam najczęściej masz normalnie tam przynajmniej tej generacji drugiej czy trzeciej NVMe ze 4 lejny. Więc no one mają zalet, natomiast no one też mają te wady, że często są w takich egzotycznych, kurde, małych obudowach i tam po prostu nic nie wsadzisz. Kibicuję ARM. Nie no, znaczy ARM spoko, tak? ARM spoko, tylko ja właśnie mówię, że Raspberry Pi jest takim gównianym ARMem, bo to jest taki procesorek na płytce, ale tam na przykład nie masz sprzętowego zegara, co czasami jest trochę problematyczne, tak? No i z ARMem są trochę te problemy, że właśnie jak chcesz jakieś treści DRM odtwarzać, jakieś Netflixy, no to z tym jest problem. Z tym jest problem, bo na to nie ma bibliotek i jak na przykład chcesz zrobić sobie jakiś tam komputerek do odtwarzania mediów, czy jakiś tam tych, no to jest z tym problem. Apple pokazał, że się da, rzeczywiście RP jest extension z bateryką do wpięcia. Znaczy, okej, jedna ważna uwaga. Tak, Apple pokazał, że się da, gwiazdka, bo wsadził miliard, jak nie więcej, w warstwę tłumaczenia x86 na ARMA, a potem podejrzewam drugie tyle, żeby deweloperzy poprzepisywali aplikacje natywnie na ARMA. Bo to, czy dana architektura sprzętowa siądzie, decydują tylko i wyłącznie ludzie, którzy tworzą na nie oprogramowanie. Jeżeli nie ma ludzi, którzy tworzą oprogramowanie, albo ludzi, którzy są skłonni przepisać soft natywnie na tą architekturę, to ta architektura nie jest nic warta. I historia ma na to przypadki. Chyba Intel Itanium, zabijcie mnie, chyba to było to. PlayStation 3 ze swoim celem, który był zajebisty, ale był też zajebiście trudny w dewelopowaniu na niego, więc jeżeli jakieś gry tam sobie haczyły, w ogóle, Jezu, ale gejoza, sam siebie oglądam, więc nawet jak jakieś gry haczyły, to najczęściej haczyły dlatego, że po prostu nie były umiejętnie napisane je dlatego, że PlayStation 3 nie miał mocy, tak? To też jest tam dosyć ciekawa historia. Ale Apple nie dość, że wsadził w to górę hajsu, to Apple ma jeszcze na tyle mocy i posłuchu wśród wszystkich ludzi na świecie, że praktycznie był w stanie powiedzieć: kończymy z x86, albo przepisujecie wasz soft na ARMA, albo wypadacie z naszego ekosystemu i tracicie jakiś tam kawałek tego pie charta użytkowników w swoich apkach. No i co zrobisz? Nic nie zrobisz, no. Pan Apple powiedział, że skacz, to ty pytasz jak wysoko. Nawet jak wsadzili, że kupę kasy. Znaczy, no mówię, no mieli ten leverage, który przymusił wszystkich. Najpierw zrobili tą warstwę abstrakcji, a potem i tak się do tego się przyzwyczaili. ARM na Macu jest zajebisty, ja się zgadzam. Znaczy, sam mam z pracy MacBooka. No nie ma w tej chwili, chcę powiedzieć, no lepszego laptopa, który będzie ci trzymał baterię. W szczególności w takim perspektywie, powiedzmy, roku posiadania sprzętu, bo często jest tak, że kupuje się nowego laptopa, czy tam z Windowsem, czy z czymkolwiek, i przez te pierwsze parę miesięcy jest taka, jak to się mówi, taki miesiąc miodowy, że wszystko działa zajebiście i potem po prostu po pół roku zaczynasz widzieć taką degradację tej baterii, tej wydajności, tego ładowania, wszystkiego. A w Macu ta bateria po roku tak jak trzymała i tak samo wolno się zużywa, tak to po prostu kurde dobrze działa. Czy to oczywiście ma tam to, że no x86 ma ze sobą masę naleciałości, to, że tak naprawdę tam mało kto dobrze go implementuje w systemach operacyjnych, nie wykorzystuje dobrze sytuacji. Przecież jaka chryja była z tak zwanymi cestanami, że te uśpione laptopy i tak się wybudzały i w plecaku jak miałeś go wsadzony i tam zżerały baterie, tam jakieś cuda nie widy, nie? A w armii właśnie trochę się odcięto, w szczególności Mac odciął się od całej tej histerii i zrobił to wszystko od nowa. No ma być teraz zresztą Windows na armię natywny. Znaczy kiedyś już były te Windows Embedded i one były natywne na ARMA już dawno. No ale zobaczymy jak to będzie teraz. Jestem bardzo ciekaw. Czy ARM wygryzie x86? Nie wiem. Wydaje mi się, że jeżeli nawet to zrobi, to patrzymy na proces, który perspektywicznie będzie trwał co najmniej 10 lat. Tak strzelam, że 7 do 10 lat dopiero będziemy mogli powiedzieć, że x86 jest passé, że już nikt nie kupuje x86 i że wszyscy przeszli na ARMA. Natomiast no, czy do tego dojdzie, nie wiem. To wymaga bardzo dużo takiego pchnięcia ze strony ludzi, którzy wytwarzają oprogramowanie i ludzi, którzy są odpowiedzialni za sprzęt. Microsoft chce teraz chyba pełnoprawny system nastawiać. Nie, no tak, właśnie to jest to jest to, co mówię, że embedded już było. No zobaczymy. Znaczy, Microsoft miał bardzo dużo takich ciekawych rozwiązań, o których dużo ludzi nie słyszało, które były naprawdę niesamowite i bym powiedział, że wyprzedzały Linuxa latami po prostu. Pamiętam, chyba było takie, miałem to kiedyś na laborkach na uczelni. To był chyba Windows CE. Aktywowałeś Windowsa XP telefonem. Tak. Było jakieś takie coś jak Windows CE i to był Windows, którego sobie dosłownie kompilowałeś na jakieś tam urządzenia wbudowane albo na przykład bankomaty i dosłownie mogłeś sobie zaznaczyć w takim klikalnym menu, czy na przykład chcesz sobie wkompilować panel sterowania. I dosłownie tu nie chodzi o to, żebyś go zenablował, tylko dosłownie wkompilować go. Czyli jeżeli go nie wkompilowałeś, to tego kodu odpowiedzialnego za panel sterowania czy pasek start po prostu w ogóle tam nawet nie było. Więc to był taki bardzo fajny, bym powiedział, Windows takich zastosowań naprawdę minimalnych, co było super ciekawe. No Windows też był systemem, który był na przykład takim prawdziwym systemem czasu rzeczywistego. Linux chyba po dziś dzień za bardzo takim systemem nie jest. No ale to taka ciekawostka bardziej. Co do Microsoftu, to też za bardzo kibicowałem Lumi, Windows Phone, moim zdaniem było świetnie, szkoda, że nie wyszło. To samo, same here, też bardzo kibicowałem Windows Phone'owi, bardzo chciałem mieć, uważałem, że to jest super prosty telefon, że te kafelki to jest po prostu zajebiście proste i nieprzekombinowane, też w perspektywie takiej, żeby dać po prostu taki telefon, nie wiem, ludziom starszym, tacie, dziadkowi i tak dalej, żeby jakoś mogli korzystać, ale jednak ze smartfona. Strasznie mi się podobało to, że Microsoft jak zrobił Windows Phone'a i w ogóle jak zrobił system operacyjny, to on powiedział, że bierzcie, jedźcie z tego wszyscy, ale warunkiem, że jakiś producent smartfonów będzie instalował OS Windows Phone'a na swoim telefonie jest to, że ma spełniać minimalne wymagania, czyli że telefon ma mieć tyle RAMu, taki aparat, tyle megapikseli i tak dalej. Przez co uniknięto sytuacji, gdzie Windows Phone był instalowany na strasznie wolno chodzących gównach, co miało miejsce na Androidzie. Przecież ile razy było takie coś, że można było telefon z Androidem kupić za niewielkie pieniądze, który po prostu chodził jak ścierwo. Po prostu praktycznie w ogóle on haczył od dnia pierwszego, tak? Mi tam brakowało tylko aplikacji. No, patrząc z perspektywy czasu, większość aplikacji w tej chwili to jest tak naprawdę strona internetowa, która mogła stroną pozostać, a jednak jest aplikacją z całym stackiem Elektrona. No cóż zrobisz. Dobra, pogadaliśmy, powspominaliśmy, ponarzekaliśmy. Dzięki wszystkim za streama dzisiaj. Może mi się uda coś bardziej regularnie robić, natomiast bardziej chciałbym robić takie streamy, gdzie mam konkretnie coś do pokazania, do przekazania. No dobra, zrobię closing note po angielsku. Thank you all for the stream today. I hope I will be able to do this more often. Ideally, I would like to have streams like this one today, where I come to you with something very specific and I know what I want to do and I know how long everything takes, and I don't have to worry about, staring into the void of Ansible playbook running for half an hour multiple times. And yeah, if you have any questions, leave a comment. Like I said, I will try to link everything in the description. And yeah, thank you for your time today, and I hope I'll see you next time. Maybe I will make a full YouTube video out of this VOD, but I think I will actually have to do something more scripted and prepared. So don't worry, this will have a more condensed and consistent form available hopefully soon. So let me see. Yeah, that's all, folks, and I hope I'll see you next time. Bye bye.